Alright, YouTube, we're here with the bench testing for the CMPro ASH26, and we're in the process of basically working out which electronic speed control we need to go with. So we're in the process of binding it with our radio. We're going to mount the prop after we figure out if the collet that I made bigger is straight. If it's not straight, then we'll have to square that. We're going to be using a 2200 3S60C. First test is going to be on a 40 amp Aerostar brushless ESC with 5 volt at 3 amp BEC. It's capable of running on 2 through 4S LiPo with reversing function on a separate channel, as compared to the 60 amp Hobby King Plush with a BEC at 5.5 volts at 4 amps, capable of running on 2 through 4S as well. This one weighs 76.75 grams. This one weighs 45.8, but keeping in mind we don't have these adapters considered into that because we'll be taking this end off and putting it on there. So this will probably be more like 48 grams or 49 grams. So either way. Alright, so we got the plane pulled up. Okay. Throttle cuts on. Tested. Okay, so we're at 0%. Not that it matters. Also, it doesn't matter which ones we plug into here, except for the fact that we would like to get this right eventually. Looks like I got to trim these just a hair. This was just kind of a haphazard, quick, get some separation between those wires sort of thing here. So sorry about that, guys. Just gonna roll this, apply even pressure with the blade, slip this off. Still gives us adequate protection, keeping these things separate from one another. Okay, so we got 1, we got 2, we got 3. We really don't care the direction of travel. At this point, we just need to make sure we keep out of the bell housing, because that will spin. And so really, the only thing I'm going to maybe do just as a precautionary measure, grab a piece of tape, hold everything in position so we know where they belong, and fold the tail over so we can quickly get that up later when we're done. Don't really care about cooling on this that much. And I just thought of something. We'll go ahead and grab no, we're not going to grab a temperature reading on this, just because I'm just going to go by a touch temperature, because really we're not loading this thing yet, so it's not going to really matter. Secondly, we're binding it first. So we got the bind plug plugged in. This is the reverse. You can see it just goes ground to signal, so there's no power being pulled. The BEC is applying power here. So when we power this up, we'll go ahead and bind it. Might as well go through our voltage meter, so don't forget to do that, or current meter rather. Which way is up on this? Oh, there it is. So we'll go ahead and plug this in next. Okay, so we're going to shut this off. We're going to hold the bind plug. We're going to turn it back on. Binding. DSMX 22 milliseconds. Okay. Okay, cool. Now, one thing I noticed about this motor is that this tag is about to peel off of here. And to be honest with you, the tag is weight. It's going to be invisible anyway. I'm just peeling it off. I'm sick of fighting it. So I'm going to go lay this on our box so we don't have to wonder where that is. This is the box for the Emax motor. So we'll just stick that on there for now. So real quick, we'll just come back around here. Okay, cool. So we've got our information here. First of all, throttle cuts on and tested. Okay, throttle cuts off. Spins up. That's full. Full throttle. Of course, there's no load on it. Okay, so second thing, throttle cuts on. We can pull the bind plug out. We don't need to worry about that now. And we can, well, we're going to set this bind plug where it belongs for now, which is with that bag. And then we're going to go back to testing whether or not our collet is square. And I can definitely tell you, not square yet. You can see pretty clearly it's got a wobble in it. So we're going to cut the throttle. We're going to just peel that off of there real quick. And then we're going to put it back on. Sorry. We're going to turn the speed up. We're going to let it run at a lower RPM because it doesn't need to be fast to do this test. We're going to grab a marker. And we're going to go until we first see a mark. And then that mark will tell us which side needs to change. Okay, so I touched it. Throttle cuts on. Now we're going to look for the mark. We can see the mark now. There's a mark there. There's an absence of mark all the way around, so that tells us our high point. So, what we need to do is we need the high point to be brought back down. So, we're going to grab the drill bit with tape on it, and we're going to spin this so that the high point goes away. So we're going to take this drill, we're going to take out the doohickey. Oops. We're going to take this. Okay, we see where the black mark is. It's right there. So that black mark is wobbling the furthest out. So if it's wobbling out, we're going to exaggerate that. So what we need to do is we need to drill up toward the mark. Okay, so we're holding this. We're going to apply pressure where the mark is. Okay, now we're going to stop and we're going to test again. We're going to wipe off the mark so it's gone. Very good. Bearing in mind that this collet will bite tight. Throttle cuts off. Lots better. Okay, throttle cuts on, sticks down. Second thing we're going to do, we're going to actually pull the collet off. We're going to throw the throttle cut off. We're going to run this smooth as a butter. So, what we're going to do is we're going to put that on. We're going to just verify fit. Nah, we're not going to do that yet. We're going to see if we can't get this a little bit better. Run the speed up. Definitely can feel a wobble. Let's see if we can mark this. Okay, we got a mark. Might have pushed it a little bit too hard that time. Nope, we can definitely see the high point. Okay, now remember the high point, in this case, throttle cuts on, by the way. It's going to be the same scenario, except we're going to go a little bit lighter pressure this time. And we're going to walk around a little bit just to clean everything up. Okay, very good. Then we're going to slide this on. Throttle cuts off. Up the speed. Feels better, but still not perfect. We're going to use a different color this time. Instead of using that color, we'll use red this time. Ouch. Okay, we marked it. The back of that bell housing has a cooling fan on it. Okay, looks like it's the same point. So we're going to go ahead and work this off again. So what that means is the same point. Okay, so we probably just need to bring it down more evenly and a little bit forward and a little bit backward. So I'm just applying pressure evenly down, forward and backward. Okay, so we got that. Now we can leave that mark the way it is. Throttle cuts off. It's getting a lot better, guys. Barely any oscillation at all. Now, there is another way to do this, and that is to use the motor to actually ream the hole, but I'm a little bit reluctant to do that even still. Oh, I guess we do need to mark it. Okay, throttle's going up. We'll use a green marker this time. Okay, touched it. First touch, throttle cuts on. Looking for the mark. You can definitely see the high mark is over on this side. Okay, so we'll go ahead and pull this off. A little bit of back and forth should loosen the collet. Okay, comes right off. And we're going to do the same thing. We'll pause it for just 1 second. Okay, so same thing we're going to do again, just a little bit more. Remember, you can't add material back. Plus, you don't overheat the aluminum if you don't do too much at a time. Okay, so we've got that ready to go. Most of the marks are wiped off. Okay, throttle cuts off. Looking lots better. Okay, throttle cuts on now. And we're getting close enough to where I'm sort of tempted to hold on to this somehow and then remount the last little bit. But let's see how it does now that we actually go ahead and mount it. Of course, I don't want to have my equipment in close proximity to this. This is clearly heavy enough to where it's not going to pull the thing. But I still don't want to tempt fate, so I'm going to give myself every advantage I can by moving everything back away. Also, I need to pay attention to what direction it's going. So it's going toward me, which would be counterclockwise, the correct way. Okay, throttle cuts on. What we'll do is we'll mark with a marker that's red. Red is red. See, I'm marking over the letters. And then we'll mark. Hold on 1 second, guys. We're going to pause it. Alright, guys. Had to switch to auxiliary power there. So basically, this step, what we're doing is we're just getting this in a spot where it's not going to fall over. And you can see that thing flopping around in there. That thing flopping around in there is actually the front half of that collet. So we need to kind of manipulate that in such a way. Probably have to use another screwdriver or something like that, and then we can use that screwdriver to kind of line up gently. Okay, there we go. Now it's on. Now we'll just take this Allen headed pan screw here. We'll go ahead and get this in here, and I've triple verified that the throttle cuts on, but just understanding that at this point now we're in a position where we could actually have somebody get hurt on this test. So I am going to grab some safety glasses and I'm going to put them on. Okay? Obviously this is going to be spinning this direction, and when it breaks it might fold back, it might not. I don't really know for sure with certainty. And there's not an overly large amount of clearance here. Just going to torque those down one more time. Okay, so let's make sure our clearance is totally clear. We're totally clearing the ground. I'm going to go up on top of this lip so that that won't get sucked up with the wind. I'm going to make sure that we're forward. Okay, throttle cuts off. I'm going to put it back on. I'm going to step right in front of you guys. Okay, throttle cuts off. And we'll just give it just a little. Okay, so everything, as you can see, is working well. We've got lots of wind going this way, just to show you. It's blowing that way. What are we at right now? We're at 0.4 amp hours. I'm going to flip this battery so that our meter gets pointed up. Okay, now I'm going to hold this down with my hand, and I'm going to give it 25% throttle. There's 1 amp, 1.2 amps. There's 2.2. There's 3.2. There's 4.0. We're at about 5, 6. Okay, we started to move, so we got to change something. Throttle cuts engaged. We went to about 5 amp hours, or amps, not amp hours, sorry, I thought it said amp hours. So what we're going to do is we're going to have to actually protect our whole rig by changing something a little bit. Really happy with the way it sounds. It sounds like it's not perfectly balanced, but we're close. So what I'm going to probably do at this point is unplug the battery just to save the battery power. And we're going to probably pause it so I can get some stuff renegotiated here, and I'll be right back. Alright guys, so what I ended up doing is I re-secured the other side of this bracket so that I can only pivot just a little bit. Okay, so it's not going to hopefully give us trouble. Throttle cut is on, by the way. We're going to go ahead and get this power back up. Just making sure our blades are folded forward. Okay, so throttle cut's off. Going ahead and okay, one thing I noticed is we must have slid back just a hair. Okay, here we go. .3 amps. Okay, there's about 50% power. We're at 7 amps. There's 10. Okay, so we maxed out at about 12 and we stopped at about 60% power. We're going to try this again. Just wanted to rearrange something back here. Alright guys, trying to give you a little bit better view. Not 100% sure you're going to be able to read this screen. Just trying to set things up so that you can actually see what's going on your own without having me read it out loud. And so far it's a little bit challenging to get this screen readable for you because there's a glare that keeps coming up. So at any rate, we'll go ahead and fold the blades forward. Throttle cut is off and we're ready to go. $14 amps there. 14 amps at 41 on the throttle. 17 amps at 57. 64 at 18 amps. 20 amps at 71%. Looks like we're maxed out at 19.3 amps. 19.3 amps there, guys. So 19.3 amps at 100% power. What I'm going to do is I'm going to do a quick succession. I want to bring the throttle up right away, just making sure nothing's burning up here. So far everything feels great. We're going to go straight up to full power within about 2 seconds. Okay, so here we go. Full power is at 20 amps. Okay, looking for inrush current. Inrush current doesn't seem to have been an issue. Okay, again. Full power is 20 amps. Okay, out of the power. Looks like we're at 20. Just feeling, making sure nothing's coming loose. Thus far, everything looks good. Full power. She doesn't get anywhere near what I expected. 20 amps is the maximum. Throttle cut is on, by the way. Tested as well. Okay, so what that tells me, guys, is that here, grab that for me, Ray. If I go with this larger ESC, what I get is really pretty much a whole bunch of nothing. So it's a little bit tempting to go even down to a 30 amp ESC. But you got to remember, this has not been on for long. It is getting a little bit warm. There's no airflow. There will be airflow under normal circumstances. And if it's just idle and it's just running servos, you're going to have servo load as well. So what I'm looking at right now is this is probably going to be major overkill. Not just minor, but major overkill. The thing is, too, we got a stabilizer. So with the stabilizer, your servos are always going to be jittering a little bit. Even if it's a minor amount, they're still going to be doing it. So what I need to do now is that, oh, and by the way, you'll notice that this thing sounds pretty well balanced. I mean, it's not perfect, but it's close. And what I'm going to do is I'm going to revisit that here for a minute. And the other thing I've learned from this test is that my theory on the oversizing the ESC, I was just getting a little bit overdone there. I could probably get away with a 30 amp ESC and be quite comfortable there, in fact. So that might be what I do. I might go with a 30 amp and see if I can get a YEP ESC that's going to give me a 5 volt or 5.5 volt at 5 amp, which will be more than adequate to run all the servos, even at crazy oscillation. So let's go ahead and take off this tip. I'm going to unpower this right now. And why don't we go ahead and get this tip pulled off. Motor's not especially hot, which is good to know. I believe from reading in the manual, you're not supposed to bench test this for more than like 60 seconds at a time or something to that extent. Okay, so now that we've got that off, it would be nice if I could put something on here to just test the collet only, but I don't think we're going to get so lucky. So we're going to go ahead and plug in our battery again, let everything initiate. Throttle cuts on. Okay, we're gonna run this up. Might as well go back to black. We've done other colors already. Throttle cuts on. Okay. First touch, throttle cuts back on. Sticks down as well, just as a safety measure in case I'd bump that switch too. Okay, so we've got this high point. Probably the same high point we've had the whole time. And what we're going to do is we're going to get our drill and do just a little bit more work on this. Find the high point. Smoothing it on both sides. Okay. You see, there's your material. So that little bit of material is now out of there. Okay, so now we can stick this back onto the shaft. Feels like we got a nice fit, real good fit. Throttle cuts off. Oh yeah, look at that, guys. We are getting really, really good here. So now, I think we're really close. Let's do one more mark. Throttle cuts off. Same thing we've been doing. Mark it. At the first mark, that's how you know where to drill or which side you need to start with again, okay? Okay. And by the way, I got this pretty close. I've got a build video for this one of the early steps. Okay, throttle cuts off. That thing gets a little warm when you do that, so you'll want to keep it to very short stints if you're going to do it that way. But now that we're so close, it's kind of hard to do it any other way, in my opinion. Okay. Look how smooth that is now, guys. That thing doesn't move at all now. So just letting it spin like crazy. Throttle cuts on. Alright, great. So, next step is going to be to go ahead and reassemble that and see if we feel any vibration under load. We're just going to try this a little different. We'll hold the screw this time, and we're just going to go in it like this. Get that screw set. I do have the throttle cut on and tested, by the way. Tighten that down. Second thing we're going to do is we're going to check our screws before our bench test starts. I got about 1/8 of a turn there. There's about 1/8 of a turn there. These blades are not going to flop around quite so much on this test, which is okay. It's going to simulate everything just fine. I'm going to hop back over here. Okay. Throttle cut is off. Holding. Okay. We haven't exceeded 21 amps yet. 21 amps on a 40 amp ESC is plenty good. Inrush is 250 watts of inrush current. Excuse me, wattage, not current. Inrush current is still like about 21. Max now about 21.79 on that one. So 21.79 is just nothing. Okay, that went to about 23. That was 25. 25. 25. But then it settles back down to about 19.5. And I'm going full power, nothing. Full power, nothing. I'm not giving it any time to smooth in. And I'm extremely satisfied with the way this is working. This thing's probably fine, but I'm probably still going to go with a, I don't know. I don't need the reverse function. I may use that in a float plane sometime, but I'm probably not going to use it in this plane. Just because I don't want the extra weight of the cable, and I'd rather have the SBC as opposed to the regular BEC. I want the switching BECs more efficient, especially on a glider. So anyway, guys, this is part 3 of the current series on bench testing ESCs and motor combos. Just so you know, our cell's down to 3.89, 11.6 for the total, 3.85, 3.86, and 3.89. So we're still doing well. Battery's not hot at all. It's not even warm. I would say it's probably room temperature. I would say we're maybe 110 degrees, 105 degrees in here. And the motor itself is about the same. So we go any smaller, we might end up bearing a little more heat here or there. So maybe 40 amps is the way to go. It's the happy medium. And I could save maybe 5 grams going down to a 30 amp. So I would say right now that might be the happy. I'm going to lose on the BEC. I don't think we're going to find a 5.5 volt at 5 amp in a 30 amp ESC. I just don't think they're going to have that in the size class. So guys, thanks a lot for watching. I know this is some tedious, boring stuff, but you know what? I get a kick out of it, so I know you will too. Thanks for watching. Don't forget to like and subscribe.